Hello, today we're going to look at long and short multiplication. So let's jump right in. So before you watch this video, I'd highly recommend watching the short video I did on the distributivity of multiplication. I'll put the link below. Once you've watched that, come back to see this because this video heavily relies on understanding distributivity. So as a quick refresher, building on what you will have just looked at when watching the distributivity video, we know that to work out 425 multiplied by 5, we can partition the multiplication to find its partial products. So we could do 400 times 5, well 4 5s are 20, multiplied by 100 is 2000. We could then do 20 times 5, and hopefully you should know your factor pairs of 100 off by heart, so 20 times 5 is 100. Let's line these up properly. And then we could do 5 times 5, so hopefully you also know your multiplication facts, and 5 by 5 is 25. So these are our three partial products, and then to find the product of these two factors, we'd simply add these together. So far so good. But this isn't terribly efficient. What we're going to do is use this and look at how we can build up to doing first short multiplication and then long multiplication. Before we do compact short multiplication, I'm going to do a transitional stage. We're going to look at expanded short multiplication. So I'm doing the same numbers so you can make the links between these partial products and what you see in this calculation. So when we're doing short multiplication, we have the smallest factor on the bottom, the largest factor on the top, and then we multiply each of the parts of the biggest factor by the smallest factor, which is exactly what we did here. So 5 times 5, well, we know that's already 25. 5 times 2, apart from that 2 is not 2, it's 2 in the tens place, which is 20. So 5 times 20 is 100. And then 5 times 400 is 2000. So hopefully already you can see the links between what we've got here and our partial products here. So the final stage to work out what 425 multiplied by 5 is, we add these together. So this is more efficient than what we did here, but it's still not as efficient as it could be, because you might notice that in these columns we've got 0, 0 and a 5, then we've got 0, 0 and 2, and here we've got a 1, and we've got a lot of zeros that we're writing out. So what the compact method does, which we'll look at in a second, is it basically squeezes all of this together, so we do our addition as we go along, so we don't need to write quite as much out, and we certainly don't need to write quite so many zeros. So let's look at what this would look like if it was compact. So we're going to keep the same numbers so you can see the links between them. So we're still going to do 425 multiplied by 5. We've still got our largest factor on top and our smallest factor on the bottom. We've got our multiplication symbol. It's always useful to remind ourselves which operation we're doing. So again, first we do 5 multiplied by 5. But because we're going to be adding our numbers as we go along instead of doing it all at the end, we do place our 5 into the ones column, so the ones from the 25 goes into the ones column. But then, because we know we are going to be adding something else into this column, what we do is we place the 2 tens from 25 here. So it's 2, it's in the tens column, so it's still worth 20, but we don't want to add it on until we know what else is going in this column. So now 5 times 2, or 5 times 20, is 100. Add the 20 is going to be 120. So now we can put that there. Then it's going to be 5 times 400, which is 2000. So we know we've got the 1 in the hundreds column, which is 100, so it's 2100. And what we've done there is we've done a much more efficient method. Let's look at another example of doing that. So this time I'm setting out just a little bit larger so you can really clearly see everything that I'm doing. Obviously when drawing your lines you'd use a ruler, but I'm trying to do this very quickly. So it is important to give yourself space because it doesn't make this easier to set out, and if it's easier to set out it's easier to read and you're far less likely to make mistakes. So the first step, we've set it out, we've got our smallest factor on the bottom, our largest factor on the top, and what we're going to do is multiply each part of the top factor by the bottom factor to find the partial products, but we're going to add these partial products as we go along. So 6 7s are 42. So 6 7s are 42. So the 2 does go into the 1s column, then our 4 10s from 42 goes into the 10s column. 6 times 2 would be 12, or we could say 6 times 20 is 120. Add the 4 10s, which is 40, so that'd be 160. So 100, the 1 would go into the hundreds column, and the 6 10s would go into the tens column. And then 6 lots of 500, well 6 5s are 30. Add the 1 would be 31, we could write here. But that 31 isn't actually 31. 6 times 5 is 3,000, which gave us a 3 in the thousands column. And we added the 100 on, so it's 3,162. So what we've done is we've added our partial products as we go along. What you might find is useful, sometimes as I go along, what I do is I cross out the numbers once I've added them in, just to make sure that I don't accidentally add them in again. So that was short multiplication. Now we're going to do long multiplication, and all long multiplication is multiplying a number. For example, let's have our largest factor as 328. And instead of multiplying it by one digit, which would be short multiplication, or we could use short multiplication to find the product, I should say, we're going to multiply it by a 2-digit number. In this case, we're going to multiply by 12. So we're going to use a very, very similar method with a slight change, and this will be long multiplication. So, as per usual, we're going to put the largest factor on top, which is 328. And then I'm going to put the smallest factor underneath, making sure to use my knowledge of place value to line my digits up. So the 2 is in the 1s column in this number, the 8 is in the 1 column in that number. So the 2 goes under the 8, so we've got our 1s in our 1s, our 10s in our 10s. Multiplication symbol to remind us what operation we are doing. Like I've said before in other videos, it's really important as a reminder, just because sometimes, especially when people are rushing, they do completely the wrong calculation. It really isn't unusual for children to do an addition when they should have done a multiplication, or even an addition when they should have done subtraction. So putting that symbol there as a reminder and checking it against the question you've been given, so we can see that our symbol matches, helps us to make sure that we are doing the correct operation. The next step is exactly the same as with short multiplication. 2 lots of 8 are 16. We put the 10 from our 16 into the tens column. 2 lots of 2 are 4, and the 1 is 5. Or 2 lots of 20 are 40, and 10 is 50, and a 5 in the tens column is 50. And then 2 lots of 300, or 2 lots of 3, put a 6 here, or 2 lots of 300 is 600. And a 6 in the hundreds column that's what that gives us. Okay. So the next step is now where this gets slightly different from short multiplication. We're now going to be multiplying this top factor by this 1, and this 1 is not worth 1. What is it worth? That's right, it's worth 10, because it's a 1 in the tens column. So what we can do is we put a placeholder here, and this means that all of our other digits are going to be shifted one place to the left, which in effect is the same as multiplying by 10. So now we go 1 lot of 8 is 8, 1 lot of 2 is 2, 1 lot of 3 is 3, or 10 lots of 8 are 80, which is 8 in the tens column, 10 lots of 20 is a 200, which is a 2 in the hundreds column, and 10 lots of 300 is 3000, which is a 3 in the thousand column. So now the last step is to add up our partial products. So 6 add 0 is 6, 5 add 8 is 13, 1 add 2 is 3, add 6 is 9, or 100 at 200 at 600 is 900, and then 3,000 with nothing else to add is just 3,000, or 3 with nothing else to add is a 3. So 328 multiplied by 12 is 3,936. And we know that answer is reasonable because 10 lots of 328 would be 3,280. With another 2 lots of, well, 300 for estimation's sake, gets us close to that. So we know that that answer is reasonable. So let's just do one final example of this to make sure that we can follow the method. So let's set this out. So largest factor on top, smallest factor underneath, lining up using our knowledge of place value, our symbol. And we're going to be multiplying all of those digits by 5. 5 7s are 35. 5 2s are 10, add the 3 is 13. 5 5s are 25, add 1 is 26. We've used those, let's just cross them out so we don't get confused. Then we've got our placeholder because we're multiplying not by 6 but by 60. 6 7s are 42. 6 2s are 12, add the 4 is 16. 6 5s are 30, add the 1 is 31. And then the final step, let's add those partial products together.